Hello and welcome to ArcGIS Enterprise Architecting Your Deployment. My name is Philip Heedy. I'm a product manager on the ArcGIS Enterprise team. And for about the next hour or so, I'll be talking all about how to take the various components that make up ArcGIS Enterprise and put them together for a functional system. The assumptions and prerequisites going into the presentation is that you're already somewhat familiar with the ArcGIS Enterprise product and the capabilities that it provides. The audience that I have in mind for the presentation is someone who's involved with architecting, meaning the logical diagramming of how to put together the different components, and or installing the different parts of ArcGIS Enterprise. Some recommended prerequisites is some prior familiarity with ArcGIS Server and the related terminology. For example, if I say an ArcGIS Server site, you know what that is. And then familiarity with general conceptual items from the area of system architecture. Things like virtual machines, load balancers, DNS, those IT things that sit outside of ArcGIS Enterprise itself. If you're already familiar with the components of ArcGIS Enterprise, such as Portal for ArcGIS, the ArcGIS Data Store, and the things that go into the broader ArcGIS Enterprise story, such as the concept of federating an ArcGIS Server site, then you're even better suited for following along here. If you're not, though, don't worry. I'll try to make sure that everything can be done. The scope of the presentation covers architecture as it relates to ArcGIS Enterprise, roughly 10.5 through 10.8. I'm not going to cover some of the other newer things that either sit on top of or are based on ArcGIS Enterprise. So that's things like ArcGIS Indoors or ArcGIS Mission. If you're working with those products, this presentation may definitely provide a lot of information that's going to be useful for you, but there's additional things that you will have to go elsewhere to find. I'm primarily focused on the components of the base ArcGIS Enterprise deployment. I'll talk about the additional server roles as well, though, and how you can use those to expand the base deployment with additional features or for scaling out. And that's actually a really big part of the presentation. All right, with enough preamble, let's talk about what I actually mean when I say ArcGIS Enterprise and the software components that go into it. This is what a normal ArcGIS Enterprise deployment looks like in the sense of a normal base deployment. There's multiple different software components that go into that base deployment. And you can see them here on the slide. We start with the ArcGIS Web Adapter. We have a component called Portal for ArcGIS. We have a component called ArcGIS Server. I'm sure many of you are familiar with that, even from prior to ArcGIS Enterprise. And then you've got the ArcGIS Data Store. Those four first components is what makes up a base deployment. And then, of course, we have a lot of additional server roles, such as Notebook Server, GeoAnalytics Server, GeoEvent Server, and so forth, that you can add on for providing more capabilities. So often when we talk at a very high level and say ArcGIS Enterprise, we're talking about these different software components at some level. In this presentation, I'm going to be taking the technical view of things, meaning specifically what are the things that I have to install on specific machines or VMs to make an ArcGIS Enterprise deployment. Sometimes when we talk about ArcGIS Enterprise, we're talking to a non-technical audience, or rather a non-IT audience, the people who are using the system and may not be at all involved with architecting or installing and maintaining the back-end infrastructure. You'll notice that some of the terminology might vary in those cases. For example, we talk about a software component called Portal for ArcGIS. That's because there is literally an installer that you download from my Esri called Portal for ArcGIS that you then install on a machine. But we don't talk in terms of end users connecting to Portal for ArcGIS. They're really just using ArcGIS Enterprise. Portal for ArcGIS is one component, but it's a back-end infrastructure component. Sometimes we might say that an end user is connecting to or interacting with the ArcGIS Enterprise portal. It's because there's a web application that we refer to in that case. But we're not necessarily using using that term to mean the same as just portal for ArcGIS. The two terms are not interchangeable, although they are obviously closely related. Next, I want to dig into a little bit to that ArcGIS Server component that you just saw on the previous slide. ArcGIS Server has been around for a long time at this point, and many of you have probably used it before we even introduced the broader ArcGIS Enterprise product and introduced that portal that came along with it. Today, we have a number of what we call server licensing roles. That's a concept a logical concept of how to light up different features from the ArcGIS Server installer, right? So there's a single ArcGIS Server install, a software component that you can download and you install on a machine, and then depending on which licensing role, server licensing role you apply to it, which license file at the end of the day, you get certain different types of capabilities. The most well-known of those is probably the GIS server itself, and the name is intentionally chosen to kind of lean up towards ArcGIS Server. So the GIS server is where you get the classic GIS capabilities such as mapping and visualization, so things like map services and feature services. This is where geocoding services, routing services from network analyst, all those things come to life. Next, we have the image server role, which is where you get the ability to publish and work with large amounts of raster imagery, first of all, things like mosaic datasets, and making them available as image services. In recent releases, Image Server also provides a wealth of additional analytics that we haven't seen before. So things like raster analytics is a new feature of Image Server that came in a couple of releases back. So at the end of the day, Image Server allows you to publish and do very, very advanced analytics against large amounts of raster data. GeoAnalytics Server is another server role that we introduced a few releases back, and it's all about working with large data sets, big data, if you will, performing distributed analytics against data sets with tens of millions, hundreds of millions, or billions of records, and doing it across distributed architectures in order to get very fast results compared to how much data you're actually working with. GeoEvent Server is all about real-time data, taking real-time observations, performing analytics on them in real time, as well as streaming them out into maps for real-time visualization as well. There's lots of powerful capabilities with how you can then act on or react to events coming into the system. And last but not least, we've got the Notebook Server, which is a relatively new addition to the ArcGIS Enterprise family, first introduced with 10.7. It integrates Jupyter notebooks. So for those of you who are working with Python, this is a really nice integrated and streamlined way of getting Python and Jupyter notebooks into your system. You can work with these interactive notebooks and write your Python code and run it inside of a web browser without having to install anything locally. You'll notice that GeoEvent and Notebook Server have a slight asterisk to them because there's a slight difference in how you set those up. In the case of GeoEvent, you take both that ArcGIS Server software component that I started off talking about, and then you overlay an additional GeoEvent Server setup. The combination of those is what then actually gives you a GeoEvent Server site. Notebook Server, it's a little bit misleading that we have an arrow on this diagram, but that was more for simplicity. Notebook Server is an entirely independent install and download from the ArcGIS Server setup that you may otherwise be working with. So you don't need to overlay Notebook Server on top of ArcGIS Server. You just download and install that on your own. All right, so with that understanding, let's talk about what a typical deployment of standalone ArcGIS Server might have looked like in the past, and then how that relates to what this new concept that we've introduced called a base deployment of ArcGIS Enterprise. In its very simplest form, a standalone ArcGIS Server had a single ArcGIS Server machine, typically connected up to a geodatabase of some kind where your data was being stored. This might be an RDBMS, or it might be a file geodatabase on your file system. It may even be shapefiles, but hopefully that's not the case for too many of you anymore. On top of your ArcGIS server side, you had a web adapter or some other kind of reverse proxy and load balancing solution. This is where requests come into the system and are sent to the underlying ArcGIS server machine that then connects to the databases or data sources and produces some kind of output in reaction to the request. By comparison, the base deployment of ArcGIS Enterprise has a few more components to it. It's no longer just that ArcGIS server machine, although that's very much still there. The workhorse of the system hasn't changed. On top, however, we now also have that portal for ArcGIS component. This is what provides both a front-end web application that end users can interact with, what we often refer to as the ArcGIS Enterprise portal, but also provides a lot of additional mechanisms for handling security, sharing, and so forth. This is really where the items or sort of the metadata about your individual services is maintained, as well as a lot of additional applications that build on top of the enterprise portal. Underneath your ArcGIS server site, what we actually call the hosting server, and we'll talk more about that concept here in a second, we still connect to different forms of data sources or data stores. You can, of course, still connect to your enterprise geodatabase or file geodatabases or other types of files on the file system. If it's an enterprise geodatabase, these are your SQL servers, Oracle, PostgreSQL, things of that nature. But now we also have what's known as the ArcGIS data store. This is a new component that's part of the ArcGIS Enterprise base deployment. It provides the ability to have hosted data, and this is a concept I'll talk a bit more about later as well. Jumping ahead a little bit, you'll see here on the slide it says relational and tile cache. That's because the ArcGIS data store comes in a couple of different flavors. In fact, there's 3 different flavors. 2 of those types or flavors of ArcGIS data store is part of the base deployment. So ultimately, when you have these different components put together, you have what a minimally functional, if you will, or as I said, the base deployment of ArcGIS Enterprise. It gives you a lot of capabilities. So let's dive a little bit deeper into that logical architecture and see how the components fit together. I talked about the ArcGIS web adapter. This is a small software component that integrates with your existing web server. On Windows, that's IIS. If it's on Linux, or if you're simply using a Java servlet container, this is things like, it could be Tomcat, it can be JBoss, it can be any of those different Java servlet containers. It really acts as a single entry point for your ArcGIS Enterprise deployment. And it's really a reverse proxy, right? This is where individual requests come in and they're distributed to the underlying components as appropriate. This is also the component that enables you to use web tier authentication. Again, if you're on Windows, this is things like using IWA or integrated Windows authentication in order to get that single sign-on type experience in a classic Windows domain. Next, we have the portal for ArcGIS component. This is the component that enables the ArcGIS Enterprise portal and serves as a web front end for many things that end users may do. It also provides a rich REST API, which is what all of Esri's own applications we build on top of. So this includes the things that I mentioned before, like sharing and identity management, item management, and so forth. You can, of course, also build your own applications on top of that REST API. So it's important to understand that Portal for ArcGIS is not just a one-for-one between that web application that many end users see, but also provides a lot of additional back-end features. Sitting there in the middle is an ArcGIS server site. This is what's known as the hosting server site. It should be configured with a GIS server licensing role and be promoted or set to be the hosting server. And this is an action that you take after first federating it with your enterprise portal and then doing a little bit more work on the configuration side. What that allows you to do is to publish and share maps from things like ArcGIS Pro. You can publish them to this server site. but you can also upload your own data into the enterprise portal and have it show up as web services. The way that I like to explain the hosting server site is that ultimately when you upload a shapefile and say create a hosted feature layer out of this, the data has to go somewhere, and that data has to be exposed through some kind of web service. The hosting server site is where that web service shows up. Where the data goes is the next component, the ArcGIS data store. When that shapefile or a file geodatabase or a CSV file, whatever it might be, gets uploaded to the enterprise portal, well, we need a place to store it. And we need to store it in a format that is efficient for publishing out as a web service. The relational data store that's part of the ArcGIS data store is that someplace. It's very much not a replacement for your enterprise geodatabase. Your enterprise geodatabase is by far the better place to store data that you need to carefully manage and maybe expose to other systems outside of ArcGIS, as well as get the full breadth of capabilities that the geodatabase provides, such as topologies, domains, all those great things. Things like parcel fabric and utility network very much live in your enterprise geodatabase, not in the ArcGIS data store. I mentioned the ArcGIS data store has 3 different types. The second one that's shown here is the tile cache data store. This is used for when you publish those 3D scene layers. When you create a 3D scene layer, we create a cache of that data, and that cache gets pushed into ArcGIS Enterprise. Again, the data has to go somewhere, and the tile cache data store is that location for your 3D scene layers. And then finally, I won't touch on the spatio-temporal big data store right now. We'll see that here in just a bit. Suffice it to say that it's related to GeoEvent and GeoAnalytics in particular. And I jumped ahead a little bit because, of course, the enterprise geodatabase that you may have is still viable and is something that you can and should connect up to your ArcGIS server sites. This is your user-managed data repository, as opposed to the ArcGIS managed data repository that we just talked about. They have very different and complementary functions, and we even have a small white paper that you may want to reference if you want to learn more about this distinction between ArcGIS managed and user-managed data stores. Search for Data in ArcGIS white paper, and you'll find it pretty easily. So all of the things that I just talked about, of course, you can also find in the online help. If you go into the online help on enterprise.arcgis.com, you'll find an introduction topic that has this section called the base ArcGIS Enterprise deployment, and it talks about these components, like I just did, and how they're connected up to each other. All right, I'll catch my breath for a second, and then we'll talk about all the functionality of the base deployment. What do you get when you've set all this stuff up? Well, first of all, you get all the same functionality that you may already be familiar with from a traditional ArcGIS server. You have the ability to publish map services, feature services, all kinds of different service types from your own referenced data sources. Again, that can be file-based, enterprise geodatabases, or in many cases also other spatially enabled databases. Additionally, on top of that, you get the ability to give users access to self-service mapping workflows. In the past, what we often saw was that a single GIS department with a few people were the one central place to go for mapping. If you needed a map, you had to go and talk to the GIS department. And there's a ton of value in that, and of course that's still something that we see and promote. But there's a lot of value in also enabling casual users to do things on their own, at least some of the more basic things. Giving them access to that web-based application that the ArcGIS Enterprise portal represents can be very empowering. And it's something that you may also be familiar with from ArcGIS Online. The Enterprise portal doesn't just give them access to self-service mapping in the sense of building their own maps from the ground up. There's also a lot of additional very, very powerful capabilities such as story maps and other configurable app templates that you and your users can make use of. You get access to Web App Builder for quickly creating web applications. There's things like Operations Dashboard for ArcGIS. There's a new feature called ArcGIS Enterprise Sites that was introduced with 10.6.1 and higher. And then, of course, you have the full suite of all of our native applications to run on your mobile devices that also connect to ArcGIS Enterprise or ArcGIS Online, as it may be. This includes Collector, Navigator, Survey 123, and many others. And finally, all of the custom applications that you or Esri business partners build using the ArcGIS API for JavaScript and the ArcGIS Runtime SDKs build on top of and connect to the enterprise portal for storing their maps, for storing their templates, for storing all kinds of different information, and ensuring that we have the right security around that. Now, we are getting into the architecture side of things. There's these 4 different components that we've talked about at length now. And you need to make a choice about how do you actually choose the right pattern, the right implementation pattern for these components. At its very simplest, you can go with an all-in-one or a single machine setup. You have a single physical machine or a single virtual machine, whether it's on premises or a virtual machine in a cloud environment like AWS or Microsoft Azure. And then you simply have all of these components on a single machine. There can be a lot of advantages to this. You don't necessarily have to split them apart, which is the multi-machine approach that you see on the right-hand side. Choosing between these 2 patterns is very much dependent on your needs, depending on how many users do you expect to have to scale for, how much infrastructure can you get, essentially how big of a machine do you have, and then it becomes a question of how to isolate individual components for each other if you are concerned about the performance given however many users that you need to scale for. And I'll dig into the individual components here later on to talk about how they scale. What I would say at this point is that the all-in-one, the single machine deployment is a really, really great and simple approach for small and even medium-sized organizations. There's a tendency for system architects that aren't necessarily familiar with ArcGIS or ArcGIS Enterprise to go to the logical extreme a little bit too quickly. I highly recommend considering a single machine setup if you have a small or medium-sized organization and you don't necessarily expect or know that you will have to scale to, let's say, thousands of concurrent users. A single machine setup can actually handle a lot more load than you probably expect. At the end of the day, though, that's a determination that only you can make based on your known needs. The multi-machine deployment is the approach to go for when you know that you will need to scale some of these components individually. For example, if you know that you will have a lot of traffic to your individual services, let's say your map services, you may have to scale out your ArcGIS Server site. And that means adding more machines. If you can't add, if you have a single machine setup, you can't add just a single ArcGIS Server machine. Well, you could, but then you have an imbalanced load. One of the machines is doing more than the others. So at that point, you should start considering the multi-machine setup. All right, so let's try to take yet another look at that base deployment and see the quick steps involved in getting it set up. You start by configuring the web adapters. After having installed all of the software and not having done any configuration, you configure those web adapters with your portal for ArcGIS and your ArcGIS Server site. Next step is to configure the ArcGIS data store and then register it with your hosting server. This is connecting the 2 components up and making them aware of each other. A similar concept is the next step, which is where you federate your ArcGIS Server site with the portal and designate it as the hosting server. Federation is what we call that step of buddying up Portal for ArcGIS and ArcGIS Server so that they know about each other, and ArcGIS Server knows that the Portal for ArcGIS is now where security is maintained. And in three fairly simple steps at this level of detail, you have set up the base deployment. To do this, we have a tutorial as part of the online help that walks you through these individual steps. Now, I highly recommend that anyone who's involved with architecting or especially installing the components do this by hand at least once to try it out and to get a feel for what's going on behind the scenes. But ultimately, it's not about deploying the components by hand. In a real-world production environment, you don't want to do that. We don't want you to do that either. There's a number of different automation tools that we provide that make it much easier to deploy ArcGIS Enterprise in the real world. For the small single machine deployments that doesn't necessarily require a lot of IT help, and for developers who are looking to set up a dev or test environment, the ArcGIS Enterprise Builder is a fantastic choice. This is an all-in-one installer, meaning it's a couple of gigabytes that you download from Esri, and then you run a single wizard-based interface that installs and configures every single one of those components on the machine of your choice. So you don't have to individually install the 4 pieces and then federate and designate as the hosting server, all the things that I just talked through and the tutorial taught you how to do. It does that for you. I highly, highly recommend the ArcGIS Enterprise Builder for anyone who is looking to set up a single machine deployment on premises or in cloud environments outside of AWS and Azure. So why do I say don't use the ArcGIS Enterprise Builder in AWS and Azure? Well, that's really because we have even better tooling designed specifically for those two environments. If you're deploying in the cloud, we provide two different but related pieces. One is we provide pre-built machine images. So in the AWS Marketplace, you will find a machine image for Windows and a machine image for Linux that already has all of the ArcGIS Enterprise components installed. You can use those machine images as a starting off point for building out your deployment, but I would actually recommend that you look at the cloud builders to do that for you. For both AWS and Azure, we have what's called the ArcGIS Enterprise Cloud Builder, and it allows you to easily deploy and configure ArcGIS Enterprise in these two cloud environments. The cloud builders have quite a lot of different options, including choosing between the single machine deployment and other more advanced deployment options. If you're in the cloud, especially AWS and Azure, take a look at those cloud builders. If you're deploying on premises or perhaps in a different cloud environment, we also provide 2 deployment options for those who have that DevOps type of workflows. Essentially, if you know and use the concept of infrastructure as code, we provide Chef, which templates, or rather Chef recipes, as it is, which is Chef itself is an automation toolkit that is available for both Windows and Linux. Very popular, and we provide these out-of-the-box recipes that does a lot of the installation and configuration heavy lifting for you. If you're on Windows, PowerShell is a scripting technology that's built into every single modern version of Windows. DSC stands for Desired State Configuration. And what we provide is a series of PowerShell DSC scripts that, again, make it very easy to script out and automate installing and configuring all of the different components of ArcGIS Enterprise. Highly, highly recommend that you use one of these options depending on where you are, the complexity of the deployment that you're looking to set up. All right, that was a lot of talking about the base deployment, getting started with ArcGIS Enterprise, the concept of choosing between the all-in-one or the multi-machine setup. Now I want to talk a bit about moving beyond that base deployment, both in terms of scaling out, how to do that for the different components, as well as scaling out in terms of functionality, adding new and additional functionality that's not part of the base deployment itself. The first component that I want to talk about in terms of scaling out from the base deployment is the portal for ArcGIS component and the portal for ArcGIS tier. The first question to answer is really, when do you need to scale out? And the answer is, for the portal tier, not very often. It's actually fairly rare that you need more CPU or memory, because the component itself is relatively lightweight from that perspective. As long as you meet the basic system requirements, you can have hundreds of users without having to worry about anything. And in many cases, depending on the size of your machine, you can even support thousands of users without even having to think about it. It's not a question of scaling out for the vast majority of cases. For storage, this is where your content that gets uploaded to the portal and generated by the portal, you can scale out by doing an in-place expansion. So your storage for portal for ArcGIS is either the local file system or optionally on a shared network storage. So you can simply add more capacity to whichever one of those two that you're using, and then you have that storage available for portal for ArcGIS to make use of. Something to note is that we have this option of high availability configurations for ArcGIS Enterprise. I haven't mentioned it yet, but for those of you who come across this, you'll notice that high availability adds a redundant extra copy of each of these components. And it may look like that's also a mechanism for scaling out. For portal for ArcGIS, that's really not the case. High availability adds an extra copy of the portal for ArcGIS component for the purposes of providing redundancy, not for scaling out. Ultimately, monitor your CPU and memory usage to see if you need more resources. ArcGIS Server gets a little bit more interesting. The first question is, when do you need to scale out the ArcGIS Server hosting server side, that's server side that's part of your base deployment? You may consider this for a couple of different purposes. The main one is if your hosting server is performing double duty, if you will. There's these hosted services, which you may have hundreds or thousands of, potentially, that your end users can generate with little to no effort. These are the kinds of services that take your CSV files and turn them into web services. Those are relatively lightweight, but ultimately it depends on how much they're being used. It's not the number of services, but how much load is being put on those services. When you combine that with the more traditional services that you may be publishing from your GIS department or more GIS power users using ArcGIS Pro, then we might start getting into some resource conflicts. The hosting server is all of a sudden both handling hosted services and these traditional services, and perhaps even doing some analytics based on requests by users coming through the portal itself. Some typical reasons why hosting server resources can become an issue is serving a lot of requests for those hosted layers, or if your users are making heavy use of the built-in analysis tools that the map viewer inside of the enterprise portal exposes, or if they're making use of those built-in analysis tools and driving them through something like ArcGIS Pro. If you have a lot of ArcGIS Insights or Insights for ArcGIS, as it used to be known, users, you need to be aware that the analytics that those Insights users are performing also happens on the hosting server side. So this is kind of an interesting little tricky area. Your Insights users can do a lot of really powerful analytics, but a lot of that compute happens on the hosting server side. So it's something to keep an eye on if you're making use of ArcGIS Insights. Next is the ArcGIS data tier, ArcGIS data store tier. Something to consider is when the use of one data store type starts to impact the other. So I've talked about how the relational data store and the tile cache data store both of them are part of the ArcGIS Enterprise base deployment. Now, if you have a lot of hosted feature layers, or you make heavy use of Insights for ArcGIS or ArcGIS Insight, then you will have a lot of data in the relational data store. users making use of those hosted layers and insights layers will be making use of that relational data store, reading the data. That's a lot of disk I/O potentially. It's also a lot of memory. The ArcGIS data store tries to cache things in order to make future performance even better. If at the same time you're publishing a lot of 3D scene layers, then the tile cache data store can start to interfere with that. The tile cache data store itself performs a lot of disk I/O as well as compute, particularly while scene layers are being published, but also when they're being consumed, that translates into disk I/O to read all that data off disk and send it back to the clients. I haven't mentioned the spatial temporal big data store except in passing so far. It's not part of the base deployment. It supports GeoEvent, GeoAnalytics, and Tracker for ArcGIS workflows that we'll get into a little bit. Scaling the relational data stores may be necessary in particular if you have a lot of users that are requesting data concurrently. Again, it's less about the number of services or the amount of data. It's really a question of the amount of concurrent requests that you need to handle. It's important to monitor the ArcGIS data store tier for bottlenecks. You can use lots of different mechanisms for doing that. Esri provides a product called ArcGIS Monitor that can be really, really helpful in this case. The metrics to keep an eye on include both CPU, memory, and disk I/O. These are classic database type workflows, and all three of those can become bottlenecks if you're not careful. The last bullet on here really just says, is a continuation of that idea of monitoring. Make sure you don't run out of disk space. I mention it really because we've seen a number of customers who ran into trouble. Modern versions of ArcGIS Enterprise handle this a lot more gracefully, but ultimately you should avoid running out of disk space to begin with. Prior to ArcGIS Enterprise 10.5.1, there were some worse behavior seen by some of the components in the cases where you ran out of disk space at the wrong time. The newer versions, what they do is they monitor the disk space internally, and once you go down below a certain point, they go into a read-only mode to try to protect the system from getting into a bad state. Just like you wouldn't let your regular database servers run out of disk space, nor should you allow that to happen for your ArcGIS data store machines. Now, let's talk about expanding out from the base deployment. I'll talk both about the GIS server, which is already part of the base deployment, and then I'll also talk about the new server roles. A couple of starting points just to level set. You can have any number of federated ArcGIS server sites within a single ArcGIS Enterprise deployment, right? That means that you can have multiple logically distinct ArcGIS server sites that are all federated with the portal. Just because you can do that doesn't mean you always should, of course. And I think the adage from before where I said use a single machine site if possible also holds here. Don't overcomplicate things if you don't need to. There's a trade-off between flexibility and complexity. The second point to keep in mind is that these different server roles have different recommendations and restrictions. Even though most of them are based on top of the same software component, that ArcGIS Server install, they behave in very different ways. So that's important to keep in mind. So as you expand out from the base deployment, there's multiple reasons and ways to do that by adding to it. The first mechanism is by adding additional GIS server sites. The typical reasons for doing this is to add additional capacity, and often at the same time to separate different workloads. I'll talk more about what I mean by separate workloads here in just a second. The second reason and method for adding to the base deployment is adding those additional capabilities. I mentioned image, GeoEvent, GeoAnalytics, and notebook server are all different server roles that you can add to ArcGIS Enterprise. Image server provides those imagery and raster capabilities. GeoEvent is about real time. GeoAnalytics is about big data analytics, processing, and then Jupyter Notebooks is what comes in through your notebook server that's been available since 10.7. So let's take a look at that GIS server site and why you might want to add additional sites to your existing deployment. First of all, you already have a GIS server site. That's your hosting server that's already in the base deployment. Something to consider when you look at your architecture is whether you need additional sites. You can set up as many sites as you need, and it depends on the needs and what makes sense for your deployment, following typically these workload separation recommendations. That's about taking different types of compute and making sure that they don't interfere with each other. Some common workloads that benefit from having separate sites are things like having highly used sets of dynamic map services. Dynamic map services are inherently very CPU intensive. And if you have a lot of those dynamic map services, or maybe you just have a lot of requests for a small set of dynamic map services, then you may be overwhelming the rest of the system and crowding out their needs for CPU, for compute. Having a separate GIS server site for just those services may make sense. Things like heavyweight geoprocessing. Geoprocessing services are enormously powerful, but they can also take up a lot of CPU, disk I/O, things like that, depending on what it is you're doing in those geoprocessing services. There's lots of different tools that do different things. Other recommendations may be for things like routing services. Their routing services are often CPU intensive, again, just like those dynamic map services. If you have workloads that have different SLAs or service level agreements from other parts of the system, you want to really ensure that these particular services have the highest possible uptime, but other parts of the system may not be as critical. You can separate them out and give them their own site. I want to make a plug for and mention the new feature called shared instances that was introduced with ArcGIS Enterprise 10.7. Previously, one reason why we saw additional GIS server sites being added to a deployment was if you had a large number of map services. Map services have traditionally been relatively costly in terms of memory. Even when they're not doing any work, a map service would easily take up at least 100 to 200 megabytes worth of memory per service instance. That meant if you had a few hundred map services, even if they got no requests whatsoever, you were consuming gigabytes worth of memory. And for those kinds of organizations where they couldn't easily scale up existing machines by adding more memory, it was sometimes easier to create an entirely separate site and add more memory through that. With shared instances, that should not be a reason to add additional sites anymore. Shared instances, without getting into a whole lot of detail, provides a much more efficient memory model for your standard map services that are published from ArcGIS Pro. So memory consumption should not have to be a driver for scaling out. Now you can focus on scaling out when you need it for reasons of bottlenecks such as compute. So what would it look like to scale out by adding additional GIS server sites? Within the white box, we have the base deployment, the different components that are wired up. And then outside of the white box, we've added this new additional GIS server site. Maybe we're using it for mapping. But you could go even further than this and say, well, I want 4 total GIS server sites. My hosting server site, that's part of the base deployment itself, but then I've added additional sites for mapping and visualization, one for public-facing map services, and a 4th one for my geoprocessing services, so I truly get that workload separation. Again, remember that each one of these ArcGIS server sites can itself be a multi-machine site, so you can add more capacity within a single site. The site is a logical construct for isolating services from each other. Each one of those logical constructs, the site can have as many machines and as much capacity as you need. All right, let's move on to image server. Image server provides 4 key capabilities. The first one is the traditional image server functionality that most of you are probably familiar with. The ability to publish dynamic image services from your own mosaic datasets, serving large collections of imagery, LiDAR, raster, and performing dynamic mosaicing and on-the-fly processing. You can have as many of these types of image server sites as you want or need. The second capability of image server is to provide a raster analytics site. Raster analytics is about extracting information from imagery. Instead of doing things on the fly, it's applying distributed processing and analysis to your imagery and raster datasets and creating new persisted output at full source resolution. When you are using raster analytics, you have one site that can perform raster analytics. You set up your image server site, federate it with your enterprise portal, and then you can designate that site and say, this is where I want my raster analytics to be performed. You can also, from raster analytics, you can separate out a raster hosting site capability. This is a new thing that came in with 10.7. So similar to the hosting server site that's part of the base deployment, which takes care of vector data, the raster hosting site is a way for you to empower users to upload and publish image collections and have them stored and made available automatically by the system. Finally, image server provides ortho mapping. This is to support Ortho Maker, which is an application that comes with image server. And it provides a series of server-side capabilities for processing satellite, aerial, and drone imagery into things like digital terrain models, DEMS, and orthomosaics. All 4 of these capabilities can, at some level, be combined into a single site. It's not that you must have separate sites, but as you'll see here in a second, it's probably a good idea to have that. We have an entire section of the documentation that talks about imagery best practices and workflows that I highly encourage you to take a look at. So adding image server to an existing ArcGIS Enterprise deployment in its simplest forms looks like this. You have your base deployment, and then you add one new image server site that does lots of different things. It can be your raster analytics site, you can publish your dynamic image services, and so forth. However, if you really want to take advantage of things like raster analytics and raster hosting, you may want to and should, in many cases, add additional image server sites as appropriate. In this example, I have 3 image server sites, one for my traditional dynamic image services, one for raster analytics, and one for raster hosting. This is an example of separating out those image server sites by capability. Next is GeoAnalytics Server, where many of the same concepts apply. GeoAnalytics Server, like I mentioned before, is about distributed computing and processing of large volumes of vector and tabular data. Similar to raster analytics that we just saw with the image server, there is a single site for GeoAnalytics Server. GeoAnalytics Server also brings with it a requirement for the third type of data store that I mentioned before. This is the spatio-temporal big data store. The tricky thing here that sometimes catches people off guard is the big data store, the spatio-temporal big data store, needs to be configured with your hosting server site, not the GeoAnalytics site itself. And we'll see why here in just a second. There's some specific recommendations about how much memory you need to provide for each machine in the spatial-temporal big data store. For GeoAnalytics Server, there's a lot of variables that go into sizing a deployment. We're talking about processing large volumes of data, so there's a tendency to go big really quickly. But you might actually be surprised at how much power you can get out of a single machine GeoAnalytics server. Something you need to take a look at your data, your workflows, and understand how your data is performing and where your potential bottlenecks are. Start with a single machine. It's simpler to manage, and then you can easily add on and scale up to 3 machines if needed. It's important to understand that with current generations of ArcGIS Enterprise and GeoAnalytics Server, we only support 1 or 3 machine configurations. Some of those variables yes, it looks a little bit overwhelming, but it's important to keep in mind as you're starting to take a look at it. Your type of data has a big impact. There's a difference between file-based data sources, such as CSVs or shape files, versus web-based data sources. Maybe you're taking data from a feature service, again, versus big data stores, such as HDFS or Hive, external resources you might be connecting to. Not to put too fine a point on it, if you're using, for example, a feature service as your input, it may not matter a whole lot how much memory or CPU that you provide to GeoAnalytics itself, because taking data through a feature service REST endpoint is not very, very efficient for these huge volumes of data. Downloading 1 billion records through a REST endpoint can take a long time, and your CPUs are simply sitting idle while they're waiting for that data to show up. That goes into that next bullet, which is the location of data and the number of files in the case of file-based data sources. Again, there's a huge difference between reading local files. Maybe it's a local hard drive and you're just reading data as fast as the hard drive can do it, versus from the network. There's network latency and then the speed of the network itself, which is that third bullet. There's a big difference between a 100 megabit network and a gigabit network. There's a big difference between whether you are allowed to and can saturate an entire gigabit network for yourself, or if you're sitting on shared network resources, maybe you are being bottlenecked by the other network traffic that's going on. If you've got those local files on disk, there's a huge difference between SSDs and traditional hard drives, spinning rust plates. Disk I/O can make a huge difference here. Size of the data, and then the ratio of CPU cores to RAM is probably one of the most important ones and easily overlooked. Often we see people who get started with this to think primarily in terms of CPU cores. More CPUs must be better. And that's not entirely wrong, but it's really important to make sure that you have the memory to go along with those CPUs. If the data isn't in memory, then those CPUs are going to be sitting idle. So the ratio of cores to memory is really important to get right. You are probably a lot better off adding more memory compared to adding more cores in many cases. All right, so what does it look like to add a GeoAnalytics server to your deployment? The simplest form is this single machine site. We've added it outside the base deployment in the middle. But then off on the left-hand side here, you can see we've also had to add the spatio-temporal big data store and connected that to our hosting server. You can scale this out to a 3-machine setup where your GeoAnalytics server site itself gets 3 machines. And then it's important to also remember to scale out the spatio-temporal big data store itself. You want to ensure that there's enough capacity there to also receive the data that's being generated. All right, moving on to GeoEvent Server. GeoEvent Server provides the ability to create GeoEvent services, real-time services, that perform data ingestion and processing. You can create multi-machine sites with GeoEvent Server 10.6 or higher, but I would recommend speaking to Esri Professional Services if you really need to go there. We'll talk about this in just a second about the different options. You can handle multiple input streams. You can handle a single very high volume input stream using GeoEvent. It all depends. If you want to archive large volumes of data, then the spatial temporal big data store is again the way to do that. So looking at adding GeoEvent Server to your base deployment, in its very simplest form, it's a single machine GeoEvent Server site. If you need to store, archive more than a couple of hundred events per second, doing that to a traditional database is often not possible because the databases in many cases can't keep up. Instead, what you will do is you will add the spatial temporal big data store. For 10.6 and higher, you can scale out your GeoEvent Server sites with multiple machines. This is for adding additional capacity and in some cases for adding resiliency. But again, if this is something you're interested in, I would highly recommend speaking to Esri Professional Services as you get started with it. Last but not least of the ArcGIS Server licensing roles that we wanted to cover is Notebook Server. This is a relatively new thing at 10.7. And like I mentioned, it provides a web-based interface, those Jupyter notebooks, for performing geospatial data analysis using Python, directly integrated into your ArcGIS Enterprise portal. You can use Notebook Server on both Windows and Linux, but because of the way that Notebook Server is architected itself, which is based on Docker containers, each notebook that gets run is actually a separate Docker container that's running. Docker works quite a lot better on Linux, and if you have a choice, we highly recommend using Linux for your Notebook Server site. This is kind of an interesting recommendation because unlike the rest of your base deployment, where we would recommend using the same operating system for each one of the components, don't install Portal for ArcGIS on Windows and then ArcGIS Server on Linux as an example. In this case, we do recommend that you use Linux for Notebook Server, regardless of whether you use Windows or Linux for the rest of your ArcGIS Enterprise deployment. There are some hardware considerations that I can't get into too much detail on in this presentation if you're running in the cloud, but if you're interested, take a look at our documentation, which talks much more about this. There's a link here at the bottom. And its Notebook Server is fairly straightforward, and how it works, you simply add it as another site and federate that with your ArcGIS Enterprise portal. So to recap a little bit, this is kind of the cheat sheet for everything that I've just talked about. When you're expanding out from your base deployment, you can add as many GIS server sites as you want. You can have separate sites for many different reasons, and this is something to carefully consider if you're running into capacity issues. For image server, you can also have as many sites as makes sense for your deployment of dynamic image services. However, it follows the Highlander model, where there can be only one site for raster analytics for your raster hosting site and things like that. GeoAnalytics also follows the Highlander model. There can be only one GeoAnalytics site. The way to scale out GeoAnalytics or raster analytics for previously is by adding more machines to your existing site. You can add as many machines as you want for raster analytics, and for GeoAnalytics you can go from 1 to 3 machines. GeoEvent Server supports having as many individual sites as makes sense for you. You may need additional sites for capacity reasons, for being able to process different streams of incoming observations. And that's completely up to you. There's no restrictions on how many sites. Notebook Server, again, it's the Highlander model. It's always separate. It's never on top of anything else, and there's only one of them. That last point is actually important to make for the other different server roles. You can, in theory, combine GIS Server, Image Server, GeoAnalytics, and GeoEvent onto a single machine and have that machine play many different roles. We very much recommend against doing this in a production environment. This is almost never a good idea, even if you're just trying to save some resources. We always recommend having them separated out unless you truly know what you're doing. For dev and test environments, it might actually be a nice feature to be able to set up both GIS Server and Image Server and GeoEvent, let's say, on a single box. But don't use it for anything beyond dev and test. Finally, I want to just talk a bit about some other considerations for ArcGIS Enterprise deployments. There's lots of things that I haven't been able to cover in this presentation, such as high availability. High availability is about adding resiliency to your deployment to reduce downtime. It comes with requirements for infrastructure, and there's some licensing requirements as well to keep in mind. You need to be able to work with your IT department for things like load balancers and management of your infrastructure. Something that I haven't touched on is the idea of using unfederated ArcGIS server sites. This is something that was very common in the past in particular. That's still very much possible, but you will be missing out on a lot of key capabilities of the ArcGIS Enterprise platform and a lot of newer applications. Keep in mind that it's important to do performance testing and scalability testing after you have architected and deployed. A plan only goes so far, and you need to validate that your expectations are met or adjust accordingly. There's lots of ways of setting up ArcGIS deployments. It doesn't have to be just ArcGIS Enterprise. You can use ArcGIS Enterprise and ArcGIS Online together. And in many cases, this can be an extremely powerful way of getting software as a service benefits through ArcGIS Online for public-facing maps while keeping other things internal. There's many ways to do this, and we have technology called distributed collaboration that helps with this. Migrating deployments is an entirely different challenge altogether. It's very different from setting up your initial deployment, and it's something that you should carefully consider if you're looking to do that. It can be for lots of reasons, whether it's new machines, new OSs, moving from on-premises infrastructure to the cloud. Something to keep in mind. Then finally, I want to talk about a few best practices and dispelling some old myths that we still hear about. One best practice that is really important if you're still on some older releases is to stop using clusters. Within ArcGIS Server sites, since 10.1, we had this concept of clusters, which was a way to subdivide a multi-machine ArcGIS Server site. We discourage use of clusters on any version. They were deprecated as of 10.5.1, and with the 10.7 release, they are flat out not supported anymore. So if you're still using clusters, then before you upgrade to 10.7 or beyond, and I hope you're planning that kind of upgrade, you need to come up with a plan to move away from using clusters. It's just not a good idea. We do want you to federate those ArcGIS Server sites. It gives you a lot of benefits, both in terms of security management and a lot of newer functionality. When you have federated your server sites, please do not unfederate them unnecessarily. When you unfederate an ArcGIS Server site, you break items, you break apps, and you will get unhappy users. There's almost never a reason to unfederate an existing site. Never unfederate for purposes of troubleshooting, for example. If you think you need to unfederate, I would encourage you to call Esri technical support and talk through your situation before going through that. We have intentionally made it harder to unfederate in newer releases of ArcGIS Enterprise for this exact reason. Finally, on the slide, use the web adapter unless you really have a good technical reason not to. It just makes things a lot easier. If you have to work with your IT department because they have other load balancing or reverse proxy systems, that's okay, but definitely do consider just using the web adapter. Then a couple of those old myths that I want to dispel. I talked about this in the beginning. We often hear the statement that there's a perception that ArcGIS Data Store is replacing the traditional enterprise geodatabase. It's absolutely not. Both ArcGIS Data Store and the hosted model, the ArcGIS managed model, and the traditional enterprise geodatabase with user managed data have very valuable use cases. We have a white paper, like I mentioned, and you'll find a link on this slide. Something that we have done work on recently that many people are still unaware of is that ArcGIS Pro can absolutely publish to ArcGIS Server. So if you hear a statement such as ArcGIS Pro can't publish to ArcGIS Server, that is not correct. ArcGIS Pro has been able to publish quote-unquote real map and feature services for a long, long time, for many years, since Pro 1.2 and ArcGIS Server 10.4. More recently, what became possible was to publish to standalone or those unfederated ArcGIS Server sites. That became possible using ArcGIS Pro 2.3. There was a scripting interface for it. And beginning at ArcGIS Pro 2.4, there's a full user experience, just like you may have been used to from ArcMap for doing the same thing, to those unfederated servers. It's a very, very valid deployment pattern for certain use cases. So while I definitely do recommend having federated servers for most things, if you are in a position where you're upgrading a standalone server site, We want you to be able to use Pro, and you can absolutely do so. It does require that you're using ArcGIS Server 10.6 or higher when you're publishing to a standalone server from Pro. And then finally, this last bullet kind of goes in that same vein. You must use Portal of ArcGIS to use ArcGIS Server. It's a common misconception. You don't. However, it's very much recommended because that's where a lot of the newer functionality and a lot of the newer applications are simply based on that full ArcGIS Enterprise stack. And then I do want to give another plug for shared instances. Beginning at 10.7, this is really a game changer. Shared instances is a concept where ArcGIS Server now has a pool of instances that are shared between multiple services, which can save you quite a lot of memory. The more map services and the more service instances you have, the more memory you can save. There are some restrictions on what can go in and make use of shared instances. So that's listed out here. Primarily is that you have to publish your services from ArcGIS Pro. This is some new functionality we were able to do on top of the Pro publishing workflows. It has to be simple map services and feature services, meaning you can't have some of the more exotic capabilities enabled, and you can't have SOEs or SOIs on services that go into the shared instance pool. However, you can absolutely have a combination. Most of your services can be using shared instances, and then a minority might have SOEs or SOIs, and they will be running traditional dedicated instances. That will still save you a lot of memory, the more services you have. Take a look at the documentation as well as the blog post linked to here at the bottom of the link. Finally, I want to round off with this. It's important that you understand what is part of the base deployment, what each part of the base deployment adds to the whole. I really want to emphasize that you should not overcomplicate things unnecessarily. Small to medium-sized deployments can and should often use a single machine deployment, even in production. Stay on top of best practices. They do change over time. Things like clusters is an example of that. Just because you learned some best practices in the early days of ArcGIS Server, 10.1, 10.2, 10.3 maybe, doesn't mean that that same advice still applies to 10.6, 10.7, and 10.8. ArcGIS Enterprise itself inherently relies on that federated server model, and there's a lot of functionality that, some of which is listed here, that relies on that. And then understand that there's different requirements and behavior of each of those individual server roles, and making sure that you use them and architect them to their fullest. And with that, thank you for tuning in. Really appreciate it. I hope to see many of you in Palm Springs next year for the Developer Summit 2021. Thank you.